Hello and welcome to our first video on VB scripting, and we're going to cover three different topics today. So starting, looping through the script, and then adding intelligence to our script. But first, let's take a look at everything. We're going to look at declaring variables and constants, identifying parts of a script, looping through the script, and our finally decision making. A little background or history on VBScript. VBScript was developed by Microsoft to develop dynamic web pages. It is a client-side script, very much like JavaScript, which is what we just came out of. And VBScript is basically a lighter version of Visual Basic. So it doesn't do everything that Visual Basic can do, but it can do what we need it to. All you need in order to work with VBScript is a code editor and a browser, just like JavaScript. So a code editor such as Notepad or NetBeans works. Most browsers, except for the Microsoft browsers, will not process VBScript. So it is very contained into what and who can run it. And it will only run on Windows machines. So if you have a Mac machine, you're going to have to test your code out on a Windows, either virtual machine or some kind of emulator, or on a Windows machine. Let's go ahead and get started and jump into it. So again, what is a script? It's a collection of commands included in a text file. It's similar to a batch file, and it can be written with something as basic as Notepad or NetBeans. Here we've got an example of what a VB script looks like. A lot of VB scripting is used to do things on a Windows machine that are more administrative. So creating network connections, asking for computer names, collecting items of how the Windows machines are configured, things like that. To run a VB script, we have a few different ways. So the first way is if we open a command prompt in a Windows environment and type C script and then the file name. So here on the left, we have an example of what it looks like when we run it through a command prompt. So here you've actually done the CS script, and it has just spit out a bunch of information about the actual Windows machine. The other thing you can do is you can double click on a file with a VBS extension. This will open it in more of a Windows GUI kind of environment. And the main difference between these two is how you receive error messages. So if you open it and run it with the command prompt, you will receive your error messages on the lines within the command prompt. If you do it by double clicking, you will get an alert window, just like we worked with in JavaScript. There are 4 parts to a script. So the first part is considered the header, and it has a bunch of information that's going to get us ready to run. The second part is the reference information, and that's where we do a lot of assignments of different things. The third part is the worker. It's going to do the bulk of the work of the script. And then finally, we have output information. This is how we organize the VB script so that other users can know where to find specific information. The header information, it is administrative. Most of it is just to tell the computer what is coming up or how to do something. So most scripts, the header can be completely eliminated and the functionality is completely the same. So it really is kind of a additional information. Here's what we're getting ready to do. It is a standard part, and it makes the script easier to read and maintain, and it controls the way the script runs. So you can see here we've got some commands that tell the computer or whatever's running the script what we want it to do. And then here we've got some information about what's coming up. So the option explicit and the on error resume next and the dim, those are the 3 commands that you will find in your header. The option explicit, what that is doing is it's telling the script that I'm going to declare my variables at the beginning. Okay. If you omit that, it assumes the variables if it doesn't recognize it. So that's very much like VB script. not using the option explicit. We are going to be using the option explicit here, and then what pairs with that is this dim. So it's dimension. It means to declare the variables that are going to be used. Now, for this, we don't need a data type. We just need to say, hey, these are variables we're going to use. So these two do go hand in hand. If I don't use option explicit, I don't need the dim. But again, for our purposes, we are going to use option explicit and we are going to use dim. The last thing is the on error, resume next. If you look at it word by word, it's exactly what it says. On an error, we want the computer to do something if it encounters an error. Resume next. What do we want it to do? We want it to resume the next what? The next what? The next line of code. So basically what it's saying is, if I encounter an error, I just want you to keep going through the script. Most of the times, the on error resume next is turned on for production and turned off for debugging and for testing. The next section is the reference information, and this section is going to assign values to the variables that you have declared or defined up in that header. A lot of times this is used because if we're using it in a batch way for a Windows machine, some of these values are very, very long text, and it is very easy to mistype them if you're going to keep typing them over and over. So we're going to set it equal to a variable to give it a shorter name and make it easier to debug. It's going to make your script easier to work with. You're going to ensure accuracy, make it easier to read. It is much easier to change later. It's very much like we think about those constants, right? We set it once and then we use it multiple times. If we have something that goes multi-line, we can actually put this command with the ampersand and the underscore to make it wrap to the next line. So we're going to use that as a continuation indicator. Can be used. It makes it a little easier to print because a print will only take so many characters wide, but it is not completely necessary. The next section is the worker information, and this is going to do the bulk of the work. So it's actually what it's called. We're going to see a few different commands here. We've got a set command, which is going to assign an object reference to a variable. So set object shell is going to be the variable, and set it equal to create object with a wscript.shell. The object shell is going to be your variable. Create object, it creates a reference to the specific object of wscript shell. Second line, active computer name equals. So your active computer name, and host name, all three of those are going to be your variables in this. Here we've got this object shell and we're going to read the register, and this is going to use those values set in the reference section to get those registry keys. So if you've never worked with a registry before, you have a registry key and then a value. So here what we're going to do is in active computer name, put the value that I'm reading out of the register of this key. Finally, the last section of the script is the output, and basically this is going to echo out any information. So we use the word echo, so wscript.echo. That is going to be like our printf in C or our outputs that we see in any other language. So for this, wscript is going to tell where to output the information. So within the script, inside a command line, it's going to be on the prompt. And if you use the double click, it's going to appear in that pop-up text message like a window alert from JavaScript. So here it says wscript.echo, the active computer name, and then we use the ampersand to concatenate it to the hard text of space is an active computer name. So this right here, when I run this script, would output the active computer name is an active computer name, and then blank is the computer name, and then blank is a host name. And it would output all three of those lines either on the command line, if that's how I ran it, or in a pop-up message box. We can create documentation while we run our script, just like in any other language, by using comments. Comments in VBScript are indicated with a single quote mark before the line that you want to ignore or comment out. So for example, here, I've got some informational text. This script displays various computer names by reading the registry keys, and option explicit forces the scripter to declare variables. On error resume next tells the VB script to go to the next line instead of exiting when an error occurs. We don't have the option of doing a multi-line comment like we do in C or JavaScript. It's single line only. So each line will start with that single quote. We can also use those single quotes for debugging and error messaging. So if I say I don't want to do the on error resume next, I can just put the single quote in front of it and it ignores that line and moves on to the next. It is very helpful in scripting to use comments because a lot of scripting is done in a type shorthand method, and it is very helpful if you go back later and you're able to see what things were or where things were going. There are some documentation standards in Appendix D of our book, and your book is free, so please go ahead and grab it. So there's some information on what can go in the header and in the reference. So in the header, the following items should be considered in the header information section: the script name, who wrote it, the date, the version if you're going to use version control, the description, and any kind of special requirements that you have. If so, do you have command line arguments? What are you doing? The reference section should have documentation of what and why we're using all the variables and the constants. Here we've got some great variable naming conventions. VBScript is very unique in its naming conventions. So here we like to start out our variable name with what it is. Remember, we don't data type. So in this case here, I might use something like, I know in the example we used reg for a registry key. Okay, so here, if I have an integer, my variable would have an int before it, a little int. Here, if it's a string, it would have a little str. And that is just to help identify what that variable is when you just look at the variable. Here, there are a bunch of common variables that are used in scripting when we use VBScript when working with the Windows machine. So these are standards that are used within the Windows environment. For example, here we used an obj shell, and it is a Windows server host shell object, WSH, and we create it by using wscript.shell. Here we've got a bunch of them: date and time. We've got some services, the networking file object, files, folder objects, and the file system object. So these tables are all available in Appendix D of your book. Some useful registry keys that are used a lot when we look at VB scripting are things like service information, username, the exchange information, group policies, home directory of a specific user, server authenticated, and DNS domain. These will have the same values on every Windows machine, but the actual data contained within this location will change based on the user of that machine or whatever user you're looking into. So, for example, the group policy server is always located under HKey current user, software, Microsoft, Windows, current version, group policy history, and DC name on every Windows machine, unless it's been changed. And we can get that information for the current user at any point in time by using these locations. Now you can see why we use that reference section. These location keys are very long. They're not very, they're not actually words. So a lot of times, like H key, local machine system, you get used to it when you're in the tech world. But for the most part, it's not something that is just off the top of your head or something that can be found in a dictionary. So we type these once, we assign it to a variable, and then we use the variable moving forward. It also makes it easier to change these later. So let's say we're going to modify some header information. Let's keep the first three the same. Let's add some variables for some new registry values we want to read. So for each registry value we want to read, we're going to need two variables. The first variable is going to be the reg variable, and then the second one is going to be the same variable without the reg. So without the reg, it's going to be the data. With the reg, it's going to be the registry key. So here you can see we have pairs: logon username, exchange domain, server, logon server, and DNS domain. If we want to change some of these registry keys, we're going to completely replace this section, but we have a pattern. So the reg variable name equals, and then we're going to give it the registry key in quotation marks. So if you want to write it once and then copy it 5 times and then just replace the various parts that need to change, that's fine too. So registry logon username equals, and then we give it the key value in quotes. Same thing for domain, server, logon server, domain. No changes there. So now we're going to modify our worker information. The first line is going to remain the same: set object, create object, WScript shell. It's going to be within that object shell that we get all of those registry keys. So in order to add those new variables into the script in the worker section, we're going to use the syntax of variable name equals the object shell dot registry read, and then the registry variable in parentheses. So the data logon username is going to equal the object shell registry read and the registry key for the logon username. So you can see here we've put our pairs matching for each other, and then we repeat that for the other 4. To modify the output information, first of all, you want to update the section and make sure that your messages make sense. So put them in a logical order as you would read it to actually make some sort of connection. But the syntax that we use is that we're going to use the command, which is going to be wscript.echo. We already talked about that a little bit. Then we're going to put the variable name and the ampersand, and then the actual text of the comment within double quotes. So for example, wscript.echo, here is my variable name, and I'm going to concatenate to it the text of space is currently logged on. Do the same for the other 4. That's pretty much what you have to do for CBC 6 Part A. Looping through your script, so we can add more power to our scripts by using loops. VBScript has a few loop syntax that are quite different from other programming languages. So we've got a for each next, a for next, a do while loop, a do until loop, a do loop, and a while when. So let's take a look at each one of these individually. For each next is going to walk through a collection of items. It's going to allow you to do something with each individual object from the collection. And in order to use the for each next, you do not need to know how many are in there. So for this script down here, we've got for each drive in the collection of drives. So up here, I've got my collection of drives and I sent it a value. And for each drive that is located in this collection, it's going to print out the drive, the size, and the free space. And then it's going to go to the next, and it's going to keep looping through here until I run out of items in that drive collection. So here I've got a constant, which is a new topic, and it is up in my header information. And instead of using the dim, we use const. And so up in that header, we say constant, we give it the variable name, and we give it the value. Then again, for each drive in the collection of drives, we give it the 3 values, and then the other pertinent information is that next at the bottom. Now, a for next is going to walk through a collection of objects, allowing you to do something for each object, except in this case, you must know how many times you're going to actually complete it. So for here, I've got 2 constants being declared. One is maximum number of loops is 8, and 1 hour is however many seconds. So in this type of loop, I say for I equals 1 to the maximum number of loops. I'm going to set the object. I'm going to echo. Actually, in here, I have a for each, which is what we just saw. But for this for, I have to have a matching next. And again, just like in any other language, you can mix and match these. You can put them within each other. It doesn't matter. A do while is going to run as long as a certain condition is in effect. So this example is also going to have an if in here with some other information and some do's, I think. So do while true. So as long as it's true, do something. And in order to complete it, we use the word loop. That's going to tell it that it wants to stop. Here we get out of this by using this exit that's down here in the if. So it's going to keep running until this happens right here in order to do the exit. A do until loop is going to run until a specified condition remains true. So do until object at end of stream, do a bunch of topics, and then I'm going to end the loop. So it's slightly different than the one before it, but they're pretty similar. Now the do loop, undetermined number of loops, can be used to monitor more important processes with alerts. So here I've got a do and I've got my loop at the bottom that's paired together. And this is just going to go through and do each of these commands until I do a break. So we usually use this as more as a monitoring process. And if something happens, we give an alert. Finally, the while when, which I think is always funny. But anyway, a while A is true, we're going to continue doing what's in the loop. And once we meet the false, we're going to exit at the when statement. So while my DTM time is greater than the time I indicated, I'm going to echo the script and then I'm going to go to sleepy time. And then I'm going to end it. So as long as my DM time is greater than time, so as soon as it becomes less than, I'm going to pop out of this one. So this is more like our traditional while loop that we have in C, except in this scripting language, every loop that we has some kind of word to indicate the completion or the end of the loop. That should be enough information to get you through CBC 6 Part B. Finally, the last section, adding intelligence, we're going to learn how to make decisions. So we've got our traditional if then, and in scripting, our if and then must be on the same line. This is very different from what we've done in the past. The action to be taken must be on the second line. With our decision making, just as with our looping, we have to end everything with a specific command word. So for an if, it's going to be the end if. So here are if and then on the same line. If A plus B equals C, then we're going to do a command and then we're going to end it with our end if. We can put multiple lines in here between the line with the then and the line with the end if. We do have an if then else if. Again, if then is going to always be on the same line. Then we're going to put the command. We're going to do an else if with the new condition and the then on the same line. You can see a pattern happening here, right? And you can repeat this else if as many times as you need to. And when you finally get to the bottom and you're done with that whole however many else ifs you have, you put your end if. So if this equals yes, then do something. Else if, here's my next comparison, then. Next line is the command. Else if my comparison, a then. Okay, and we can just keep doing that as many times as we want. We can also have an else as a catch-all, which would do this final thing, and then we finally end it with that end if. Here, if then else, so again, if and then on the same line, the command, and then we just use the word else, and then the command for the other option, and we end it with an end if. Now, select case. This is very similar to what we did in C. So select case and the variable to evaluate. We have case 0. We're always starting at 0. Case 1, 2, 3, 4, 5, case else. Here, you can repeat as many times as necessary. You can actually delete them. So if you don't have a case 0, you can just start at case 1. Say you don't have a case 3, you can go directly from case 2 to case 4. Not a problem. So the case and the value are on one line and then the command on the next, and you just repeat that as many times as you need to. At the end of a case, we have another end select. So select case, end select. If you want to have a catch-all for your case, you can have a case else, and that would be if it does not fall into any one of these categories up here, it's going to automatically do this one down here. So we went through a lot, and with that last bit of information, you should be able to complete CBC 6, the last part. But we've talked about declaring variables and constants, identifying parts of a script, looping, and finally decision making. This is the end of our VB script video number 1, and I will see you next time.